Neanderthals and Homo sapiens. How did they live? How did they meet?
This tells us that it was a case of cannibalism.
Were they killed by the local Neanderthals?
If you sequence the DNA of people living today, you can see that all people outside of Africa carry between 2 and 5% Neanderthal DNA fragments.
Neanderthals, our closest relatives. They've been extinct for more than 30,000 years. What role did modern man play in their demise? Several caves in the limestone cliffs of Germany's Swabian Alb Mountains show traces of Stone Age peoples, both Homo sapiens and Neanderthals. Researchers from the University of Tübingen have been digging here in the Hohle Fels, or Hollow Rock, for over 45 years. And just what the archaeologists and anthropologists have uncovered from tens of thousands of years ago is particularly fascinating.
Not so far ago, I got my master's degree in Jagiellonian University in Krakow, in Poland, and actually I'm mostly interested in Neanderthals. They basically are the closest species or subspecies of us, and I'm wondering how much they were actually different, how much we want to see them as different from us, and how we can define being human.
We're digging up history. We're trying to find artifacts of early modern man, and down there where my colleagues are, of Neanderthals. We want to find out what happened to them and how they lived. The current rumor claims they mainly ate big game, meat. But here we see they made use of small mammals, still meat, sure, but also fish.
Fish-rich waters are still near the cave today. The fish could not have entered the cave on their own. The animal remains, such as bones, must have therefore been left behind by humans as waste from their meals. This gives us an idea of what Neanderthals ate over 40,000 years ago, at least in the Swabian Alb Mountains.
We can only make regional statements. What's here is very different from what happens in France, for example, where we have a direct transition to modern man, or even layers that keep alternating.
In the small French village of Saint-Césaire, Isabelle Crèvecoeur and her team from the University of Bordeaux are excavating an important site. It was once used by Neanderthals as a campsite. Archaeologist François Lévesque found Neanderthal bones here in 1979, and archaeologists have since been working to uncover ever larger areas, hoping to learn more about Neanderthals. But they have not yet had as much luck as Lévesque's team.
They actually found the remains of a Neanderthal person. It is one of the latest Neanderthal found in France and in such a complete preservation. And you can see that there was part of cranium, part of upper limb, lower limb, so a lot of bones were preserved, and that is quite exceptional.
The exceptional preservation meant the skull could be puzzled together from the fragments. And based on the shape of the skull, forensic anthropologists were even able to reconstruct the face of this Neanderthal woman. Her appearance is similar to people alive today. At the Max Planck Institute for Evolutionary Anthropology in Leipzig, Philipp Gunz is researching our similarity with Neanderthals.
The most indisputable ancestor of modern humans and Neanderthals is Homo erectus, who were well-adapted hunters who lived in Africa and Asia.
The oldest Homo erectus fossils are around 2 million years old. The species originated in Africa and then eventually colonized Europe. These early humans gradually changed over thousands of generations. Their skulls became larger and longer, and they became Neanderthals. But Homo erectus evolved differently in Africa. The skull became rounder, the forehead and face straighter. The result? Homo sapiens. The discovery means Neanderthals can no longer be considered our direct ancestor, and that the cradle of humanity was in Africa, a scenario almost no one would have believed 40 years ago. Back then, a young scientist from England overturned conventional wisdom. Today, he is research leader in human origins at the Natural History Museum in London, and one of the most renowned experts on the evolution of our species. Chris Stringer.
I certainly started to develop the idea from my PhD that Neanderthals did not make good ancestors for us. So looking at tiny bits of DNA inherited through females from mothers to daughters, when modern data from around the world was put together and you build evolutionary trees from it, it suggested that all of that mitochondrial DNA traced back to Africa. So by 1988, Peter Andrews and I published a now influential paper where we talked about the genetic and fossil evidence for the origin of Homo sapiens. So that was the first detailed presentation of the genetic and fossil data together, arguing for a recent African origin. And it was very controversial.
Stringer's theory was revolutionary. Anthropologists had assumed that humanity originated in Europe or Asia. The research has been complicated by the simultaneous existence of several types of humans. When Homo sapiens set off from Africa to explore the rest of the world more than 150,000 years ago, they encountered different relatives along the way. Neanderthals in Europe, Denisovans in Northern Asia, and in Southeast Asia, Homo erectus, who had first appeared in Africa some 2 million years ago. And that wasn't all. The Indonesian island of Flores and the Philippine island of Luzon were home to extraordinary species. Adults on Flores were only 1 meter tall. All have long since disappeared. Only we, Homo sapiens, have persevered. Why? Researchers are hoping to find the answer in artifacts and bones. Did Homo sapiens and Neanderthals lead significantly different lives? What did Neanderthals eat in what is now France?
This is a tooth from a horse. To find this allows us to connect the stone tools and the animal found and say that this was probably part of an activity of this human group. They were hunting, they were bringing part of carcasses, they were processing the carcasses here to extract the meat, obviously to eat.
But how do the researchers know that it was really slaughtered? Couldn't a horse have just died in the cave by chance at some point?
We have some marks that were left on these bones that were left by humans. And we have very, very tiny marks on them right here that were left by a stone tool that was used to remove the flesh from it. And so clearly to, remove the meat to eat it afterwards.
The work of experimental archaeologists like Rudi Walter proves that such traces actually come from stone tools. He tries to recreate the scars discovered by archaeologists and is often able to show that the traces he leaves on the bones today correspond to those made 40,000 years ago.
They didn't just carve out a cutlet, they really used everything, starting with the hooves. Sometimes there are cut marks on the bones. They can be made into rattles or jewelry. They also use the skin, the fur of the animals, for clothing, for tents, for cooking pots. You can also cook in the skin. The tendons here on the bone are dried and then defibered. They can be broken down into fine strands. And then you get an incredibly strong thread that I basically cannot tear.
The research involves a constant interplay between discovery, hypothesis, and practical tests. Researchers from different regions also help each other by sharing what they've learned at conventions like this one in Aarhus, Denmark. Martina Lech from the University of Tübingen presents news about an astonishing find from the Hohlefels.
The dates that we have is around 60,000 years ago, so it's around 20,000 older than we assume. So it suggests that it's totally connected only with Neanderthals. So our perception that we thought that Neanderthals are incapable of making something like that without influence of Homo sapiens is now should be put in the history of research, but not of the current research knowledge, because it showed that we just didn't understand that Neanderthals maybe are a little bit more complex than we assume.
If they didn't come from Homo sapiens, then what historic weapons did we use? Clues can be found at the CEBU Cave in South Africa. A team from the University of Tübingen is on its way to the excavation site, but the journey is not easy. A river blocks the way with no nearby bridge. A climb awaits on the other bank. But the extra effort is worth it. People have sought shelter under this rock overhang for the past 45,000 years, and they've left behind a trove of treasures for archaeologists.
CEBU is incredibly rich in finds. We have buckets of sediment less than 10 liters that contain thousands, 2,000 stone artifacts. The find density here is enormous.
Many of these finds are specially made pieces of pointed stone. Some include indications that they were once affixed to arrows and spears.
I am now looking at a piece that has probably been hafted with the use of ochre. The production of glue requires planning, it requires several steps, and identifying the exact recipe of these glues is crucial.
Testing such recipes is Rudy Walter's specialty. He uses only ingredients found on the pointed stones to recreate the glue.
In South Africa, in CEBU, we found the remains of a red material on the pointed stones. It turned out to be a mixture of beeswax, tree resin, and red chalk.
The mixture is heated in the fire, leaving a viscous, sticky mass that hardens as it cools. Perfect for attaching a pointed stone to a wooden shaft. Walter then wraps the spear in string to add stability. Spears were probably the most important Stone Age hunting weapon. They were given an important upgrade around 18,000 years ago, the atlat. By extending the throwing arm, spears could be thrown much faster and much farther. A direct comparison illustrates the difference between spears thrown with bare hands and those with an atlat. More than twice as far. Were Homo sapiens able to out-hunt Neanderthals thanks to better weapons technology? Might they have even attacked Neanderthals directly? A special find from Belgium shows that there were indeed deadly clashes between different types of humans in the Stone Age.
It's such a nice piece. We have Neanderthal bones that show such marks. And in these instances, we also see that the bones were processed to remove the flesh. They were also broken to get to the marrow. We compared the traces that were left on them with those left on animal bones and saw that they were the same. So we know that those Neanderthal bones were processed and then used in the same way as the animals that they ate in these places. And so this tells us that it was a case of cannibalism.
These bones were found in the CEBU Caves in Belgium, where the remains of several Neanderthals were found. Not all showed signs of slaughter. Researchers decided to look at isotopes from the remains to determine the difference. The isotopes helped Sarah Pederzani determine the origin of particular stones or bones.
Isotopes are just two versions of the same chemical element. If you take a chemical element, for example, carbon, there's the little brother and the big brother, so to speak. And they are actually found everywhere. There are different isotopes in me, there are different isotopes in this stone I'm sitting on.
The same is true for other elements, such as strontium or sulfur, and the ratio of their isotopes differs from place to place. Everyone absorbs these isotopes through drinking water and food. As long as bones and teeth grow, isotopes are incorporated into them. The isotopes therefore reflect where someone spent their childhood, no matter how far away this person later moves. Bones can be used to reconstruct whether they grew up in the same place they died or somewhere else. The isotopes reflect the geology of an area. The elements leach from rocks into drinking water and from there into bones. They leave behind a kind of fingerprint specific to a certain region. Analyzing the isotopes identified the origin of the CEBU Cave's Neanderthals. Many came from what is now Belgium, but not all.
What is super exciting is that these are exactly the fossils where there are cut marks on the bones, where you can see, okay, a form of cannibalism has taken place, and only with the individuals that came from somewhere else.
While isotope analysis goes a long way in helping us fill in our family tree, genetic analysis is now providing even more precise information.
We now have whole genomes, high-quality ones, of a few Neanderthals, and that really confirms our close relationship to them. It suggests that we had a common ancestor with them maybe 600,000 years ago. And remarkably, even though we went our separate ways maybe 600,000 years ago, we've come together with them from time to time, and so there's been interbreeding. So everyone around today has a little bit of Neanderthal DNA in them.
But how do you get DNA? It becomes increasingly difficult as bones age.
In these hard bones, inside these bones, the DNA is quite well protected from the effects of bacteria or other contaminants. Some organic material must still exist. A fossil that is completely fossilized, something that is, say, 1 million, 2 million years old, unfortunately no longer contains any DNA. But bones that are, say, 200,000 years old and have been stored in a cave, like a natural refrigerator, sometimes still contain enough DNA to be extracted.
To extract DNA, a small hole is drilled into the bone. The resulting fine bone powder is mixed with various chemical solutions. The goal is for only pure DNA to remain. The actual DNA analysis is largely automated. A PCR machine amplifies the DNA contained in the sample to ensure that enough genetic material is available for analysis. This glass plate is coated with molecules that can hold DNA fragments. The solution containing the sample passes over it, and the DNA binds to the appropriate places on the glass. A kind of striped pattern forms on the platelet because certain DNA fragments only stick to certain places on the glass. The machine can recognize this pattern on the glass platelet. It determines where the 4 basic DNA chemicals are located, allowing the computer to decipher and display a DNA sequence as a sequence of letters.
Discovering that fragments of DNA can now be extracted even from Neanderthal bones that are more than 50,000 years old was revolutionary. That was a pioneering achievement by my colleagues here at the Max Planck Institute, for which Svante Pääbo also received the Nobel Prize. And one of the things this makes possible is a better understanding of the relationships between different groups.
Thanks to groundbreaking work at the Max Planck Institute in Leipzig, the differences in the DNA sequences of Neanderthals and modern humans can actually be determined, literally to the letter.
Neanderthals and modern humans are very different in terms of parts of their genome, but fundamentally, we are of course extremely closely related. So closely related, in fact, that my colleagues were able to show that modern humans and Neanderthals could successfully interbreed.
The first encounters between anatomically modern humans and Neanderthals may not have always been hostile, because the species mated with each other. These sexual encounters left genetic traces that can still be found in the DNA of Europeans today, but not in that of most Africans.
Why we have no or hardly detectable Neanderthal fragments in people living in Africa today is because these mixtures took place outside Africa. In today's Israel, that was certainly a hybrid zone, where we can also provide fossil evidence that there were Neanderthals and Homo sapiens, and also parts of Asia, and possibly even in Central Europe. But we don't currently know of any Neanderthals who lived in Africa and who could therefore have interbred.
The first modern humans who arrived in Europe from Africa around 50,000 years ago repeatedly mated with Neanderthals, and the resulting children passed on their genes to the next generation. But the further Homo sapiens spread, the faster the Neanderthals disappeared, leaving only us. Are we responsible for the extinction of our nearest relative?
Then Homo sapiens comes on the scene in Europe, and the Neanderthals disappear within a very short time. The Neanderthals were gone in just a few thousand years. For a long time, it was believed that these were warlike conflicts, direct conflicts. But it's very, very unlikely that this explains the disappearance of the Neanderthals, because the population density in Ice Age Europe was extremely low. We're talking about 100,000 people at most, spread across the whole of Europe. This means that it's difficult to imagine that they would have wiped each other out, whether through fighting or infectious diseases, or through competition for food resources. What the genes tell us is that the Neanderthals made a contribution, so to speak, to humans living today. And what this means is that the Neanderthals were absorbed into the Homo sapien population. In other words, The Neanderthals were significantly fewer, so they disappeared into the much larger Homo sapien population.
We didn't evolve from the Neanderthals in an evolutionary sense. They didn't change into us, but they are partly our ancestors. So it's a kind of paradoxical thing. We didn't evolve from them, but they are our ancestors.
Knowing the Neanderthals' extinction wasn't violent is somehow reassuring. They just became a part of our gene pool. Neanderthals were not wiped out. Instead, their genes were simply diluted by the sheer number of Homo sapiens. Or that's the theory. Many questions remain unanswered. The early history of mankind remains intriguing.